Welcome to Mr. Powers Teaches Algebra. We are going to solve a linear system in 3 variables. Now, minimum requirement for a system with 3 unknowns to have a unique solution is to have 3 equations. 3 equations, 3 unknowns. And this is what we got. So let's start fiddling around with this. And the method, the strategy is going to be the same as with 2 equations and 2 unknowns. It's exactly the same. The problem we always have with these systems is that we got too many variables. We just want to solve for one variable. We know how to do that. Here we got 3 variables, which is a little overwhelming. So our first goal is always to get rid of the variables. So we get down to one variable and then we can back substitute. That's always our strategy. And so the first thing I want to do is I'm going to rewrite this middle one, okay? We're going to rewrite it, and I'm going to multiply it by 2. So we're going to get this. We're going to go 2 times that guy, 2x plus y plus z. Oops. Equals 4. We're going to multiply that whole thing by 2. And we can do that because really I'm just multiplying the left side of the equation by 2, the right side of the equation by 2. So I'm going to get an equivalent equation. And but it's going to be equivalent. It's going to look the same. It'll have the same solutions, but it'll look different, which is fine. Okay? And so we do that. I get a new equivalent equation to that middle one, and it's going to be 4x plus 2y plus 2z equals 8. And there's a reason I'm doing that. What is the reason? Why do I want to do that? Let's see here. Couple reasons. I mean, one nice reason you'll see is that now each of these 3 have a 2y in them. And what will happen if I add, let's say this is equation 1, this is equation 2, this is equation 3, and now we call this one equation 4 over here. So what happens if I add 1 and 4 together now? So let's get 1 and 4 together, and let's add them up. So let's see here. 1 is x minus 2y plus 3z equals 7. And now we add those up. What shall we get? What shall we get? We shall get 5x. Ooh, negative 2y plus 2y is 0. That's just gone. So we love that. And then plus 2z plus 3z is 5z equals 7 plus 8, 15. Whoops. There we go. Okay, so now I get another equation. Yet another one. I guess we could call this equation 5. Right? I'm going to stop eventually here with these numbers. Okay, so I got a new equation. And now what's nice about this equation is this equation has no y in it. I got 2 variables now, which is great. Can I play around with another 2 equations to get rid of y? I definitely can. Let's see here. So this was 1 plus 4. What about 3 plus 1? If I'm looking at this, 3 plus 1, the y's will cancel out there also. So let's do that. Let's go ahead and add up 3 plus 1. So we're going to take equation 3 plus equation 1. Let's do that over here. Okay? So 1 was x minus 2y plus 3z equals 7. And 3 was negative 3x plus 2y minus 2z equals negative 10. Now, is this the only way I could have done this? No. I could have, we did 1 plus 4, the last one. I could have done 4 minus 3. And I could have changed the sign on all of these, then added it to 4. And that would be another way to get rid of 2y. So there are lots of options here, lots of ways to get rid of y and create a new equation in just x and z. But that is what I'm trying to do. What I'm trying to do is get down to something I know already, and that is 2 equations, 2 unknowns, because now we're experts at doing that. We're experts at doing 2 equations, 2 unknowns, so let's get down to that, 2 equations, 2 unknowns, and then we'll be able to find those 2 solutions, the 2 variables there, the solutions for those variables, x and z in this case, that work, and then we'll be able to figure out y. So what do we get here? Okay. What are we getting? Let's see. X plus negative 3x is negative 2x. 2y and negative 2y is 0. 3z minus 2z is 1z equals negative 10 plus 7 is negative 3. There we go. So now I have yet another equation. We'll call it equation 6. Now, look at this. Equation 6 and equation 5, they're exactly what we want. We have 2 equations, 2 unknowns. We've done that before. We're experts at that. This is going to be so easy. Now I can keep the elimination thing going, or I can start using some substitution. It's really up to you. I don't know. You know what I'm going to do? I'm just going to multiply this times 5. So I'm going to get, what's 5 times equation 6? And I'm going to keep just canceling things out, right? So now I got 2 equations, 2 unknowns. I need 1 equation, 1 unknown. So let's multiply equation 6 by 5. So sorry about this. And I'll get another equation. Multiply everything here by 5. And we're going to get negative 10x. Oh, you know what? Let's multiply it by negative 5. Then I get positive 10x minus 5z let's see here, equals positive 15. Then yet another equation I can play with. And now, what's the deal with that equation? Well, if I add this one to this one, what comes out? I get no more z. My z is gone. I have 1 equation, 1 unknown. That'll be x. I can start solving and back substituting. So we are almost done with this delicious, amazing example. So let's add these up. So let's see here. What I'm going to get is 5x plus 5z equals 15. And over here I got 10x minus 5z equals 15. All right, we add those up. And what am I going to get? Yet another equation that should be true, because our assumption is what we started with was true. And using all these steps, we're keeping that trueness. It's all good. 5x plus 10x, 15x. These guys cancel out. 15x equals 30. Well, that's easy. Divide both sides by 15. I get x equals 2. I know my solution for my system. If there's a solution, the x is going to be 2 in each of these. If x is 2, there's some y and some z that's going to make all of these true, if there is a solution to the system. Okay, great. Now I got x is 2. We can start just going back and finding out what's z, what's and then what's y. So let me see now. For x equals 2, I got lots of options. I could plug it in this equation here that I've circled. I could plug it in this equation that I've highlighted. I plug in this one, and I'll just have z. This one seems like the smallest numbers. I just want to plug it in there. So let's plug x equals 2 into equation 6. And what I'll get is negative 2 times x. Well, x is 2 now. I know x should be 2. Plus z equals negative 3. All right. And let's finish that up. Negative 2 times 2 is negative 4. Negative 4 plus z equals negative 3. Add 4 to both sides, and I get z equals 1. Look at that. We're making progress, and it's so fast now. Once we got one variable, the others are going to come out super quick. Now I know z must be 1 in each of these. X is 2, z is 1. What's y going to be? Well, you know what? This one had 1y by itself. That's the equation I want to plug in my z and my x into. That one right there. And I'm going to be a little lazy here. And let's just do a little cut and paste just to remind myself what that is. And let's paste that right here. We got that equation. Let's go ahead and plug our x and z into this guy. Here, we're going to go, shoom. That's going to go in. That's going to go in. What do we get? We're going to get 2 times x equals 2 plus y plus z equals 1 equals 4. Now we can solve for y. 2 times 2 is 4. Plus y plus 1 equals 4. 4 plus 1 is 5. So I really have 5 plus y equals 4. So what does y need to be? Absolutely needs to be negative 1. 5 plus negative 1 is 4. I got my solution. My solution is x is 2, y is negative 1, z is 1. We can leave it like that, or we can write it as it wouldn't be as an ordered pair. I guess we could say ordered triplet. We could write it like this if we want, as a point in 3D space. But negative 2, negative 1, comma 1. That's our solution. And if we want to double check and be really careful, we plug it into each one of these to make sure it works for all of them. So 2, negative 1, 1. 2, negative 1, so that'd be 2 plus 2 is 4. And then 1, that would make this 3. 4 plus 3 is 7. It definitely works for the first equation. It works for the second one because that's the one we used. Be quick and easy to see if it works for the third. And hopefully you understood also, while I was working on this, that like I picked this equation. I had an x, I had z, I know what they need to be. And I use this equation to solve for y. I could have used any one of these equations I started with that had the 3 variables. It's just that one looked like the simplest to me, and would just make these steps a little bit easier here at the end. So that's why I picked that. That's how you do these. That's how you solve 3 equations with 3 unknowns. Get it down to 2 equations, 2 unknowns, and then find your 2 variables, plug them back in, get your 3 equations, 3 unknowns. Easy. Easy. So just like linear systems with 2 variables. So hope you found that useful. Until next time, enjoy doing math.